Hello, everyone. Thanks for joining us today. My name is Stefano Doni, and CTO and co-founder of Akamas. I am pleased to welcome you to this webinar. Today, I'm so excited because we are going to talk about AI and performance engineering, and especially we are going to listen to the story of Sabre, the company who adopted Akamas to solve their optimization challenges. So we are going to see the challenges, why they adopted Akamas, and the benefit that Akamas provided to the company. So I also wanted to express my gratitude to the performance engineering community because actually we got really high interest in this webinar. So actually we reached more than 300 people joining this webinar. So that's, I think, a testament to the interest in the intersection between AI, machine learning, and performance engineering. So we know that AI today is changing a lot of industries. So also have a look at the question that you asked in the registration form, and I guess the main question that performance engineers have is actually how AI is gonna benefit the performance engineer. So what kind of change is AI bringing to the profession? So, and also have a look at the actual real life example of how AI can help performance engineers to, for example, optimize application in practice. So we are going to share exactly that in our agenda today. So before starting, a few housekeeping notes. So we have about 30 minutes of content today. Then at the end, we are going to have a Q&A session. So please use the chat box that you find in the GoToWebinar UI to ask any question you may have. And then at the end of the talk, we are gonna answer. And also, by the way, that's a common question. The webinar is recorded, so you are going to receive tomorrow the presentation deck and the link to the registration. So that is it. I guess we can get started. So I have the pleasure to be here today with Pawel, Senior Performance Principal Software Engineer from Sabre. Hi, Pawel. How are you?
Hello, Stefano. Hello, everybody. My name is Pawel, and I have a pleasure to be with you guys and talk in Stefano about our experience regards of implementation, optimization, one of our application at Sabre using the Akamas software. So I will have a couple of things I would like to share with you, how we did this, how was our experience in regards of all those topics. So be prepared for some good news, I think.
Right, that's great. So let's get started. So actually, before diving into the content, what is Akamas? Actually, Akamas is an autonomous optimization platform. So basically, we use artificial intelligence to optimize the configuration of the software stack. So we help performance engineers, SRE, DevOps to actually maximize application performance, reduce cost, and improve service reliability. So we have at Akamas a pretty unique ways to optimize. So first of all, we are full stack. This means that we can optimize basically the configuration on the whole stack, including the infrastructure, things like pod, CPU and memory in Kubernetes, HPA, etc., but also the application that runs within the pod. So settings like the JVM. And by the way, we are going to see an example exactly on this use case. Second aspect, which is key, is goal-oriented, meaning that you as a performance engineer can actually ask what is the goal of the optimization. So for example, you might ask to reduce the cost, or you might ask the AI to actually improve application performance. Third point, it's automated. This means that AI Akamas doesn't simply gives you a report about what you need to change in the software configuration, but AI actually, Akamas actually automates this process as well. So actually changes and automate the end-to-end performance tuning process for you. And fourth, it is safe. That's very key, and that's another unique capability that we have, meaning that while we optimize for cost, for example, Akamas always takes into consideration your application performance and reliability targets in order not to introduce some unwanted effects. So that is it. So I guess now, Pawel, the stage is yours.
Yeah, the couple of words about our company, who we are. So honestly, there is one sentence which good describes our business. That means that together with our customers, we make travel happen. What does it mean? So if you are going to book your flight, hotel, car, or whatever, actually, Sabre is a company which delivers platform to do this. So we partner with the airlines, with the airlines, with the hoteliers, with the agencies to make your travel happen. So we use the technology that powers the travel. We are in a cloud, we are in a Google Cloud, and so we are around the world. Right, so we can go to the next slide when I'm going to say something about our team who was responsible for doing the stuff. Yeah, Sabre performance engineering team. I'm part of this team since 2008, as far as I remember. We are a group of the engineers with the different skill sets. We are programmers, we are system engineers, we are SREs, we are analytics, but with one mission: help our customers to improve the performance of their applications. That's why our goal is to guide application team how to, first of all, run performance tests, analyze the results, find bottlenecks, optimize and tune applications. So we deliver the platform for automated performance testing and also destructive testing. And we tell how to use it. Our challenge is to improve the stability and performance of the Sabre applications.
Great, Pawel. And by the way, if I may ask you a question here, we worked together pretty quite a bit recently, and actually I've the pleasure to see how much advanced you are as a performance engineering team. I know that you set up quite a bit of automation around performance tests, a portal to let other application teams to take advantage of performance testing capabilities. Can you describe a little bit more, despite you have this maturity, the challenges that you still needed to solve, and what motivated you to look into Akamas?
Yeah, first of all, we were thinking about how to optimize, application in a fastest way, right? In the past, for example, when you want to optimize the application in a standard way, let's say you want to improve the JVM, right? So you have to reconfigure the application configuration. You have to restart the application in a manual way. You have to run a number of the tests, repeat them over and over, collect the results, analyze the results, apply the new configuration, and so on. So we decided to find the solution to automate this process in a repeatable way, and then do this much faster than it was in the past when we spent, I don't know, weeks to automate this, to do this, and that's why we decided to go with the Akamas.
All right, thanks for sharing that. I'm gonna go to the next slide.
Yeah. What was our journey to optimization when we decided to go with the Akamas? So we as a Sabre, we have different applications. We have applications written in C++. We have application Java-based application. So we did a lot of optimization. As you can see on the screen, those are the JVM application and C++ applications. However, we decided to also check different optimization options, like not only modifying the JVM parameters, but also when we are talking about the optimization in a cloud, we decided to optimize the Kubernetes parameters like the CPU memory, as well as a GCP for the VM instances, and finally also we played a little bit with the Linux optimization. So keeping in mind that we are in the cloud, we were working on a different environments, GCE for the VM instances and then GKE for the Kubernetes. Right, so we can go to the next slide when I have because as I mentioned on a previous slide, we had different applications during our during our journey with the Akamas. However, there is one when we got the significant improvements and I'm going to talk about this application, this specific. This was the Java-based application for our, internal booking system. When you want to, book something, some book and shop flight tickets, reserve hotels, or rent the cars, you are using this application. This is pure Java application. So we decided to optimize this application to reduce the cost. And as I mentioned, we take under consideration two optimization packs. One for the JVM, when we wanted to improve the throughput of the application, increase the throughput, the number of transactions per second, by modifying the JVM parameters, as well as in the same time trying to reduce the CPU utilization. And so this is the Kubernetes application. So we decided to manipulate the Kubernetes CPU and memory parameters, limits and request parameters, right? So that's why we had two optimization packs in place. So
cool.
go to the next slide, Stefano, or maybe. Yeah. Okay. What is the optimization process? There are actually three main points to start the optimization process. The first of all, we have to create the goal. So we have to define what we are going to achieve. If we are going to reduce the cost of the application utilization, but also increase the throughput, the number of transactions per second, we have to define the formula which will be counted, which will be prepared, counted by the Akamas itself. So the goal is the first stage. The second stage, we have to think about the constraints. We want our application to work under specific conditions to meet SLO, and then which means that we need to take care of the response time on a level which is good for us, and as well of the number of as well as the number of errors, percentage of the errors, and so on. So that's why if we define the goal, we have to also take under consideration the fact that we should think about the constraints. Response time, error rate, GC time, those are the constraints. Those were the constraints for our application. And finally, what is the optimization scope? We decided, as I mentioned, to do the optimization using two packs, trying to reduce the CPU utilization and also trying to improve the throughput. So we were manipulating the Kubernetes CPU and memory parameters, as well as the manipulating of on tuning JVM parameters to increase the throughput of the application.
All right. Thanks, Mark, for explaining this. I just wanted to stress a few messages here, because that's actually one of the questions we got a lot in the forum was how AI can change how performance engineers work. And I guess you can start to understand. So with Akamas, actually, prior to Akamas, you needed to tune manually all those parameters in the hope of basically impacting an higher level goal that you wanted to achieve. For example, reducing costs while not impacting application performance. With Akamas, actually, it's an AI-based system that lets you change completely this process. So basically, the process starts by you as a performance engineer defining what you want to achieve. So in this case, the goal was actually a formula with JMeter transaction per second divided by the number of CPUs of the pod. So it's a cost efficiency matrix. So you want to get higher throughput and lower the amount of CPU. Actually, so that's the way that you can describe using metrics what to the Akamas AI. Remember, it's goal driven. You want to describe what you're going to achieve. And also the second piece, you want to, of course, say, okay, those are my SLOs. So that is as well very important, because we have a lot of cloud optimization solutions that just look at CPU and memory usage. So you don't get to a result that enables you to kind of not to preserve the application performance and reliability. So with Akamas, you can literally ask actually to provide better configuration that still match your performance requirement. And last piece is that, as you can see, what you are going to optimize is also very different with respect to other tools, like you see the full stack nature that we are talking about, so the infrastructure piece, but also the JVM, the application runs inside, because if you don't tune the two layers at the same time, of course, you run the risk of having, I don't know, wrong configuration that put the application at risk of out-of-memory errors, or you might even make the pod bigger and not adjust the JVM settings so that the JVM won't be able to use the new resources. So is that how it works, Pavel? Or
yes, exactly. Good explanation, Stefano. Yeah, good addition.
yeah,
Yep.
thank you. I don't want to oversell things, so just how things work.
Yeah.
All right, so that's the actual how it works slide. So I guess many of you typically ask how it works. So I can probably explain the general process and then pass the ball to you to explain how did you actually put in place at Sabre. So basically, what you see in this slide is on the left. This wheel is Akamas optimization process, 4 phases, and on the right, the target system is basically the application that you are going to optimize. So in this case, the application is basically a Java-based microservice running on Kubernetes. So you see the JVM and the pod, basically, those 2 icons. And the process works as follows. So first of all, you see at the top, you see apply configuration. This means you remember Akamas automate the optimization process, doesn't simply give you a kind of report to act manually. So actually, apply configuration means that Akamas actually connect to the system and changes the parameters, changes the JVM settings, changes the pod option for you so that everything is automated. Second step is, of course, to understand how good is the new configuration. Of course, you need to put the application under load. So in this case, we are integrating Akamas in a performance testing environment. So the idea is that Akamas launches a performance test. What is important to stress here is that we don't have a performance testing tool inside the product. So it's not that you need to reinvent your performance testing scripts with Akamas. Akamas will simply leverage what you have defined. So in this case, it's JMeter. So it will launch your JMeter performance test without any further requirement. Third point, which is important, is of course for the AI to understand if the configuration is actually good. We need metrics, of course. So the third point is collection of metrics. Again, how do we do that? We don't have agents, but we integrate with whatever observability tool you have in place. And basically, that the last piece is the most important one, is actually where AI machine learning kicks in. So we have applied the configuration, we have triggered a load test, then we have measured the results. Now AI kicks in and actually analyze the load test and then understand what should be tuned next. So how should we tune the JVM and the pod to improve the goal that we have defined before, like I want to have higher throughput or lower cost, etc. So that's the whole process. Now, Pawel, can you describe how did you actually apply it into your environment?
Yes, because we were testing this application in the Kubernetes environment. So as you heard on when I was talking about what kind of the parameters we changed, we had 2 optimization pack. One was dedicated for the Kubernetes, another one was dedicated for the JVM. So we changed to more than. We used 2 optimization packs. However, we had a different configuration changes needed during one cycle. So one cycle, when the Akamas is trying to reconfigure the application. So in our case, CPU and memory was taken from the one optimization pack, while in the same time we were trying to modify the JVM parameters. I don't, as far as I remember, it was in a config map or the deployment configuration file for the application. So when we changed this, we applied the configuration. Actually, we let Akamas to apply these configurations on the namespace size, on the namespace when the application was deployed, and then the application was redeployed. So when the application was ready, we executed the test. We, as a performance engineers, as I mentioned, we have a platform for the testing. So we let Akamas to trigger the entire process of running performance test, right, with against the application with the new settings. So Usually it took 1 hour to complete one round of the testing, right? With the new settings for the application. And when test was completed, Akamas collected metrics from the different monitoring systems, from the end-to-end metrics, for the end-to-end metrics from the load driver, for the application and container metrics from the GCP, Google Cloud Platform, right? So all those things collected landed inside the Akamas, and Akamas decided to apply the new configuration and repeat this test over and over after some good stuff is found, right?
Great, great, thank you. And then we are going to see, I guess, in the next slide, what is the actual results that we achieved. Actually, before that, the baselining process, which is very important. I know that you are very kind of wanted to share this message to the performance engineer.
Yeah, so actually, before this is very important thing, and this should be underscored at this point. Before we start to optimize anything, we have to define the baseline. So we have to run a number of tests. I mean, number of the different tests, trying to define the good baseline with the, let's say, default parameters for the application. Actually, those ones which are working on a production system, like the CPU, memory utilization, CPU request, memory request, CPU limit, memory limit, something like this, and then also the JVM parameters, default JVM parameters for the application. Maybe not default, but those defined by the application team, right? So after this, we run number of let's say test, trying to define the baseline. You may think, okay, why you executed 6 tests to define the baseline? The answer is very simple. We wanted to be pretty sure that those results are repeatable, the first of all, and the environment is stable enough to run the optimization. So that's why you can see that the 6 different tests were executed trying to find the baseline. In most cases, as you can see on the graphs, they are repeatable because those are the metrics visible on a screen. Stefano can comment also on some words about this.
Yeah, the comment I wanted to add is that there are 2 features here, that 2 capabilities that performance engineer actually love because it helps automate everything. Is that you see here basically 6 performance tests executed one after the other with the same identical configuration in this case. So it's very easy once you have set up the integration like we have shown in the previous slide. So basically you just ask Akamas to baseline with 6 performance tests. So you don't need to do anything manually. So those are simply executed one after the other. But also what is important is the automatic analysis of the performance test. As you can see in this chart, there are those vertical dashed line for each performance test. That is actually the analysis Akamas did on each performance test to identify, for example, in this case, what was the maximum throughput that the system could reach doing a performance test. So the top line, we didn't put the legend here, not to clutter the chart, but the top time series is the throughput of the application. So that was kind of a ramp-up test that you put in place here, Pavel, right? So Akamas actually analyzed and identified the period where the throughput was highest and stable. So it's not simply the peak, but it also analyzed the stability of the throughput. So after this, basically baseline, you will get from the UI that the actual aggregated score. So it's a baselining and scoring that gets done automatically without any action.
Yeah. So going next slide. Yeah. So let's start the optimization, and let's actually talk about the optimization in numbers. So first of all, we have executed 17 experiments. You have to be understand what is the experiment. So one experiment is the process of changing application parameters, deploy, restart the application, run a test, collect metrics, do a scoring, and apply the new configuration, right? So this is the one experiment. So we have executed 17 experiments with a different configuration in regards of the CPU limit, memory limit, and then also a couple of JVM parameters we decided to tune during this optimization process. So finally, one experiment is also divided by the two trials, right? So every one experiment will have two trials, which means that we have to be pretty sure that even if you have the same configuration, we are going to repeat the same, the test with the same parameters for the application twice, right? To be pretty sure that those results are also repeatable, as well as the environment is stable. So finally, we got 88.8% of the improvement, significant improvement. So the best number we got according to formula we have defined in a goal. So we reduced the number of the CPU utilization and we increased the throughput by modifying different parameters. We will tell about this later on the next slide. And which is most important, we spent only 1.5 days to run this optimization. I'm not talking about the analysis results, but only the time needed the time Akamas needed to run the optimization process, 1.5 days. So we can imagine if we compare to the what was needed in the past when we wanted to optimize the JVM parameter for the particular application, we spent maybe not weeks, but at least a couple of days trying to modify parameters of the application, restart the application, run several tests, analyze results manually, look at the graphs, the metrics, everything. Right now, everything was done automatically by the Akamas.
Awesome.
All right.
Next slide about the best configurations, the usual question that we get at this point for performance engineers, and what did Akamas change to reach this result, right?
Yeah. So as you can see on the screen, we reduced the pod size from 4 to 2 CPUs. On a JVM, Akamas adjusted a couple of JVM parameters. There are plenty list of the JVM parameters Akamas can operate on. However, we decided to have a few of them. So as you can see on the screen, we modified the heap size, new size, GC threads, and so on. Finally, as you saw on a previous slide, we got the significant number of improvement in regards of the optimization, right? So, well, the best configuration is the proof that the Akamas did this work for us, right?
Cool, very cool. And also, if I may stress this point, because actually, again, performance engineer asked, how AI can help. The thing is that if you look at the parameters, if you are into, for example, JVM tuning, because a lot of people ask it, okay, how can AI help specifically JVM tuning, which is a hard problem for Java application, as we all know. As you look at the results, so what is interesting is that actually, for example, Akamas made the heap size, total heap size, max heap size smaller. So kind of change that might be counterintuitive. But at the same time, for example, the new size, so the region of the heap where new objects get allocated was made bigger. So why did the AI come up with this change? Because actually, according to the goal, we wanted to reduce the cost, but still preserve application performance. So that's how AI works. So it lets you actually match your goals while optimizing the full stack automatically. So the beauty of that is that we didn't have rules inside the product that says, okay, it is better to reduce the heap or increase the garbage collection threads. AI found it out automatically on the specific application, of course. If you change the application, the best configuration will be different, of course, but still it is important to understand that, for example, garbage collection thread were increased because you had latency constraints. Some other times, garbage collection threads may be decreased. So that's how AI works. So you will find out the best configuration for your specific requirements. So saving you a lot of work.
Yeah. Maybe one comment from my side as well, because you can see something like the GC type. Of course, Akamas, in regards of the JVM optimization pack, can modify the different GC type, right? So we finally we found that we will stay with the same. Actually, Akamas did for us. Akamas decided to stay with the same GC type concurrent mark sweep as it was on a baseline. However, you can imagine that Akamas also tries the different GC types and the different the parameters for the different GC types during the optimization process, right? So this is not only like we were focusing on one kind of the GC type. No, Akamas did a lot of different round of the optimization with a different GC type. Believe me, especially for this application, I'm pretty sure. But also, as I mentioned previously, we had different examples in during the optimization process when we played with the different GC type, trying to find the best configuration for this dedicated application.
Great. Thanks for the comment. It makes a lot of sense. And also, this one is related to the impact on performance, right?
Yeah. So every optimizations brings some insights. So looking at them, you can check not only the best configuration according to the to the goals and constraints you had in a study definition, but also how different parameters can influence the application itself. So you can imagine, you can see what during the optimization process, what was the best, for example, response time for the particular JVM setting? What was the best, the throughput? What was the best CPU utilization and stuff like this? So finally, what is the conclusion? Application response time and error rates stay on the defined constraints SLO after optimization. And we reduced the over 50% of the cost with no impact on the application performance.
Great.
Yeah, we can go to the next slide, I think. What are the conclusions from the optimization? Well, significant cost reduction. It was mentioned previously during our conversation. I can underscore it one more time. We reduced the number of CPU cores per application pod. We did this very fast. Optimization process took 3 days, including analysis, results, and so on. Akamas spent 1.5 days only to deliver us the best results. And what are the next steps? Because you may ask, okay, what else? We did optimization. We have a good configuration. Actually, the candidate for the good configuration. So what next? So usually we let our application teams to apply this configuration on a different environment, right? And repeat those tests and see the results. Like we are working on a dev environment, so let's do the same things on a certain environment, repeat those tests and see if the improvement is as visible as we had on our environment when we were testing this. So those are the three. Those are the the next steps we should follow when the optimization is completed. Okay, what did we learn? We learned a lot actually during the optimization. The first of all, we learned that we have to have dedicated environment, right? It is very recommended to have it for testing, because in most cases we will book the environment for some time, and then we should have it only for our usage, right? Nobody else should interrupt us. So dedicated environment is must-have for such kind of the experiment. Workload analysis, realistic load. In other words, what does it mean? We have to be pretty sure that we are mimic production traffic with the number of transactions, with the not only number, but also the type of the transactions. So we have to cooperate with the application team, and the application team responsibility is to prepare the good workload for us, because on a production, or at least on a environment which is so close to the production, we will repeat those tests with the new settings, and we have to be pretty sure that the results will be accurate, right? So that's why the workload analysis is something very important. Well-designed test environment. What does it mean? You may imagine that the application is not a standalone application from some time. It relies on a different third-party stuff like the downstream services. So you have to prepare everything accordingly. Databases which are connected to the application. Some maybe mock services if you are not going directly to the third-party application. So everything should be scaled accordingly, and especially if you are working in a cloud environment. And the stable baseline, something I said at the very beginning of this discussion. We prepared the baseline. We spent some time to prepare this baseline. As you may remember, we had the 6 trials for the baseline when we identified the good one, and we actually confirmed that the environment is stable and those results are repeatable. So the baseline is something we will compare the results from the optimization process.
Great. So I guess those are very interesting for the best practices that you actually learned for the performance engineering community that is following us. So thanks for ensure that they will find very valuable.
Okay. Benefits. The last slide we have, Stefano, right? So there is a couple of benefits actually. I would say the most important is very fast way how you can optimize the application. Really, believe me, when you are familiar with the Akamas, Akamas is very intuitive, by the way. It has the GUI and the command line interface, very intuitive to the end user. So if you are familiar with this, you can run the optimization process very fast, and then you can receive every experiment. You will receive the results from the optimization, so we can compare on a GUI what is the current status of the optimization, right? So very good. Actually, talking about how fast is Akamas, it's worth to mention that really it speed up the process of the optimization. Automation, everything is done in an automatic way, right? No need to kick off a test, no need to apply the configuration in a manual way, and so on. You will instruct what Akamas should do, and Akamas will do this for you. We'll apply the configuration, we'll run a test, we'll collect metrics from the different monitoring systems, etc. Support from the Akamas. I can say it on my example. Those guys know what to do, and then they are very helpful. So I can confirm that we did incredible work together to optimize not only one but the different couple of different applications, and the cooperation was very good. And finally, we have a satisfied customers. From our perspective, customer is the application team. When you can go to them and say, okay, how is it going? How your application is behaving right now after these modifications, after those optimization process, and all the time we have something like this. All right.
Thank you, Pawel, for sharing, and also also from our side it is always great working with you guys. So thanks a lot for our cooperation. I guess now we have the Q&A, but before actually opening to the question, I have one last question for you, because actually it is. Of course, you have close to 16 years experience in performance engineering. So now we have major trends that are happening in the industry. So they are quite bit impactful for performance engineering. So we have the cloud, we have cloud native architecture, we have AI, both as a helping hand, like we see with Akamas. We have AI workloads that are coming, so very massive GPU workloads, etc. So in these shifts in the technology that are kind of big trends for the performance engineering, how do you see the performance engineering in a way skill set is going to change? What will be the next role of performance engineers?
Well, I think that now automation and then artificial intelligence is coming to our rooms, definitely. so a lot of things will be changing. Trying to automate those processes is something which will speed up, our daily task, definitely, right? So because we actually expect to do some things faster than it was in the past. So that's why, in my opinion, the idea is to automate as much as possible all the time, and the optimization and tuning process is one of the good example. How can we speed up this, right? So taking under consideration that we can engage artificial intelligence, machine learning mechanism is something good, right? So in my opinion, there is no better example to tell about, right? So Akamas is one of the example which we can utilize against the application if we are going to to speed up the process of the optimization. And then this is not only dedicated for the particular one of the optimization, like the JVM or whatever, right? We have plenty of different optimization pack. We didn't talk about all of them, right? But Akamas delivers a lot of different options how to optimize not only application but also databases and so on, right?
All right, thanks for the insightful answer. That's great. I guess we can open a Q&A. I'm looking at the question that lots of questions actually are coming through the chat. I guess we can directly, very easily answer a couple of those, which are actually related to what you were saying. So I see a cluster of questions around the technology that we support. So does it support non-JVM based application? Does it support monolithic application deployed in the cloud that doesn't use Kubernetes? Does it support AWS cost optimization? So the answer is yes, as Pavel said. So we have the concept, by the way, of optimization pack that Pavel actually told us many times is the technology support that we have within Akamas. So the AI can optimize actually many parameters, many different technologies. So definitely, it's not just about the JVM. It's not just about Kubernetes. I guess that's a very interesting question, I guess. And then I think we need to close looking at the time, which is what was the weirdest configuration suggested by Akamas that actually improved the application, but your team didn't consider or was not aware of. That's interesting. Pawel, do you want to take this one? I have, of course, my answer, but it would be interesting to hear yours as well. The weirdest configuration suggestion from Akamas that you didn't consider.
Honestly, I don't remember. I do not have any results right behind my eyes. I don't. Maybe you know more than me, Stefano.
Yeah, well, one answer, there may be different situations. So, for example, optimizing full stack databases, we have seen that, for example, making the operating system slower actually improve the performance of the database that runs on the operating system. So that's kind of weird, and it has to do, it has explanation why that is the case. It has to do to the way that the database works and does IO operation, for example. Or another example is on the JVM. So everybody on the JVM, by the way, is focusing on reducing the garbage collection time. So because actually garbage collection is a stop, is a pause, and the thing is that if I reduce the pause, the application will be faster, right? But there's an interesting blog post that we have published on our website, which is actually one of the most visited blogs, where we demonstrate we let Akamas improve the application response time. So the goal was to reduce the latency, and the best configuration that Akamas recommended actually increase the garbage collection time. So that's kind of counterintuitive, but again, it has an explanation why, if the GC is pausing more, the application response time is lower. So it has explanation. So I recommend you to look at the blog post. It has to do with the way garbage collection works at the actual thread. So it's kind of a bit complicated, but there are explanation. That's the beauty of the ability to actually ask AI, what is your end goal? Instead of focusing on kind of proximetry in the technology, you ask the end goal, and sometimes the AI recommends you something that you didn't consider that actually makes the application run faster and being cheaper at the same time. So I guess that is it regarding the time that we have today. So thanks a lot, everybody, for the active participation. Thanks again, Pawel, for sharing your story. Really appreciate your time and all the work that we have done together. So as we said at the beginning, we are going to share with all of you the registration and the deck tomorrow or in the next few days, along with a survey. So please take a few moments to fill it up so that we know how we can improve. So for any information, just reach out on LinkedIn and on Akamas or with Pawel. So that is it. So thanks again. Thanks, Pawel.
Thank you, guys. Thank you, everybody.
Thank you. See you next time.
See you.